Lesson 7-6, Growth and Decay. In this video, we're going to learn to solve problems involving exponential growth as well as exponential decay. So, vocabulary for this section is compound interest, and that's the only one. So, first thing we want to look at is an equation for exponential growth. Okay, so our equation is y equals a times 1 plus r to the power of t, where a is the initial amount. So whatever we're talking about growing, it's the amount you start with. T is the amount of time, and r is the rate of change expressed as a decimal. So if something increases by 50%, 50% as a decimal is 0.5, so we would use 0.5 as r. Okay, and then y is the amount that we end up with after this rate is applied over a certain amount of time. Okay, so if we have a population in 2008, the town of Flat Creek had a population of 280,000 and a growth rate of 0.85% per year. Write an equation to represent the population of Flat Creek since 2008. So we want to first start with our equation. So remember, our equation is y equals a to the 1 plus r to the power of t. So remember, a is how much we start out with. So they're saying they had a population of 280,000. So that's what I'm going to put in for a. Okay, and then it has a growth rate of 0.85%. Now, this is a percent. We want to write it as a decimal. So to go from a percent to a decimal, if you guys remember, we want to move the decimal twice to the left. So this is going to be the same thing as 0.0085. That's what I'm putting in for r. So this is going to be 1 plus 0.0085. And then this is to the power t. So we want to write an equation to represent it. So they're saying for any amount of time. They don't give us a specific amount of time, so we just want to leave it as t. So this is going to be our equation. And the last thing we want to do is just simplify this right in here. So we're going to rewrite this as y equals 280,000 times 1.0085 to the t. So we can just do that addition there. There's nothing else we can simplify because we don't know what t is. Okay, so we leave it there. For part B, now they're saying, okay, well, what is the population in the year 2018? So if we started in 2008 and we went to 2018, how many years have passed? So that's what we're going to put in for t. So between 2008 and 2018, there have been 10 years. So we're going to say t is 10. So we're going to go back to the equation that we wrote, which was y equals 280,000 times 1.0085 to the t. And now all I'm doing is putting in t for t and solving. So this is going to become to the 10. So then we just put that into our calculator and we figure out what we get. So let's start with 1.0085 to the power of 10. That part here becomes 1.08832, etc. Okay, and then we're going to do this times 2800. And this becomes 304,731. So this is going to be our population in the year 2018. You guys try this. Okay, the next thing we want to look at is an example of compound interest, which is a type of growth. Okay, so in this case, compound interest, we're talking about interest that is being applied in a continuous type thing. So, or not continuous, this is just compounded. Okay, so A is the current amount, so it's the amount that you're looking to figure out how much interest they're going to have after a certain amount of time. P is called P because it's the principal. When we're talking about money and interest, we call it the principal. It's also the same thing as our A in the last equation. It's the initial amount. Okay, here our rate is still expressed as a decimal. Whatever percentage it is, we still write it as a decimal. Now the new thing here is the N. N is the number of times the interest is compounded each year, and T is the amount in time, or the still time in years. So if I say I have interest that's applied 3 times per year, in that case, our N is 3. Okay, so there's some things to keep an eye out for is the different words. So if you say like monthly, then you would say, okay, monthly would be 12 times in 1 year. If they say weekly, then we know that there's 52 weeks in a year, so N is going to be 52. So just pay attention to what they're saying and then think of what that N would be. Okay, so when Jing Mei was born, her grandparents invested $1,000 in a fixed rate savings account at a rate of 7% compounded annually. The money will go to Jing Mei when she turns 18 to help with college expenses. What amount of money will Jing Mei receive from the investment? Okay, so we're going to use our equation. Actually, I think I have it. I do. Okay, so this is our equation. Remember, P is the amount that she started out with. So when her grandparents first invested it, the initial amount was $1,000. So that's what we're going to put in for P. Now, 1 is given. What is our rate? They say it's 7%. So we want to write 7% as a decimal. So remember, we move it twice to the left, and that becomes our 0 there. So it's going to be 0.07. Our N is how many times it's compounded per year. Here they said it's compounded annually. So it's just every year they're going to compound it once. So our N in this case is just 1. And then 1 again. And T is the number of years. So when she was first born to when she was 18, 18 years have passed. I'm going to do times 18 in the power there. Okay? So this is going to become 1,000 times 1.07 to the 18th if we simplify a little bit. And if we put that into our calculator, 1.07 to the 18th times 1,000, we're going to get 3,379.93 cents. So this is how much money she'll have for college after she turns 18. Okay, you guys try this using the equation. Okay, the next we want to look at is exponential decay. In this case, this is where the amount is decreasing with time, whereas before we were looking at things growing and stuff. So here it's the same. All the variables still mean the same thing. The only difference between growth and decay is in this case it's minus the rate. Okay, so it's going to be 1 minus whatever the rate is as a decimal. Okay, so let's do one of these. During an economic recession, a charitable organization found that its donations dropped by 1.1% per year. From before the recession, its donations were $390,000. So write an equation to represent the charity's donations since the beginning of the recession. So again, we're using that equation. It's y equals a times 1 minus r to the t. So a is the initial amount. So in this case, our a is 390,000. Our 1, we just keep the same. Our percent as a decimal. Remember, this is a percentage. So we want to make a decimal, so we move the decimal place twice. So it's going to be 0.011. And our t is what we don't know. That's just going to be part of our equation. And then we just want to go through and simplify this. So the only thing we're going to do is do that 1 minus 0.011. And that's going to become 0.989. Put a 0 there. Okay, to the power t. And then we leave our 390,000. Okay, so that's our equation. So in part B, now they want us to estimate how the amount of donations 5 years after the start of the recession. So now they're telling us, okay, what is that when t equals 5? And we're going to plug that in. So our equation was 390,000 times 0.989 to the t. And now we're just going to see what that is when we put in t. So this is going to be 390,000 times 989 to the power of 5. So I'm going to start by doing to the power of 5. This part over here becomes 0.94619 blah blah blah. It continues and then times 300. So the last thing we're going to do is now we're going to do the multiplication. Make sure when you guys are doing these problems, you're paying close attention to the order of operations. You do the powers first and then you multiply. Okay, so this becomes 369,016.737. Okay, so here we can see that if they used to be $390 or $390,000 per year, now it's only about $369,000 per year. So you can see that the amount of donations is decreasing because people are making less money, which makes sense. Okay, so you guys give this a try and then you guys are done.